Alright, welcome to this last of 4 kind of application/review videos. This one's probably the least interesting in terms of applications, but maybe the most important in terms of review, since we only spent one day on game theory. To follow along, like with the other videos, you're going to want to go down and click the link below and download the Word worksheet, which has problem number 5. Yeah, number 5 on that worksheet includes all the information about the problem that I'm talking about. So the setup is that we have 2 firms, Pepsi and Coke, and they are competing by making identical cola. That's actually pretty accurate, despite what some of you people might think. And the marginal cost of producing this cola is close to 0. So close to 0, we'll just pretend it's 0. That also is probably pretty accurate, considering it's just sugar water. Finally, the industry price for a gallon of cola depends on the total quantity produced, essentially saying the more cola that people produce and then need to sell, the lower the price is going to be. And essentially I just copied a table from the textbook where it talks about Jack and Jill and selling water and things like that. It's the same model, but now we're talking about cola firms because I think that's cooler than Jack and Jill. Alright, so the first thing we're asked to do is to show that each company making 40 gallons of cola is a Nash equilibrium, and we're told also that since the firms are identical, if Pepsi is playing a best response, then Coke is too. So essentially, to show that Pepsi and Coke would be playing Nash equilibria strategies, we need to show that Pepsi is playing a best response with 40 gallons. It doesn't want to do less than 40 gallons. It doesn't want to do more than 40 gallons. So we'll need to do 2 calculations, basically. The first calculation is, suppose Pepsi produced 30 gallons instead of 40 gallons. So Pepsi, to organize ourselves, we'll say Pepsi's profit table. And now we'll do, suppose the quantity is, several different quantities. What would the price be, and what would its profit be? Revenue and profit are going to match up exactly here. There's no cost. Remember, marginal cost is 0, so that'll make calculating profit a little easier. So if Pepsi makes 30 gallons, and Coke continues to stick to the agreement and make 40, then the total number of gallons is 70, and our table tells us the price would be 50. And our profit would then be 30 times 50 is 1,500. That's pretty good. Another possibility is we could just stick to the agreement and do 40. In that case, the price would be $40 because we would be making 40, Coke would be making 40, so the total quantity is 80. And then if the price is 40, oh no. Sorry, technical problems. All right, so the price is 40, so then our profit would be 1,600. So that's better than 30. 40 is a better response than 30, but maybe 40 is not the best response. If it's not the best response, then we can't be in a Nash equilibrium because everyone is playing the best response in a Nash equilibrium. So we'll consider, what if we made 50? If we made 50 gallons and Coke stuck to the agreement and made 40, then there'd be 90 total gallons and the price would fall to $30. And then we can see that 50 times 30, that's kind of like exactly the same as 30 times 50. So either way, if we produce less, we get 1,500. If we produce more, we get 1,500. The best we can do for Pepsi is to stick to the agreement and make 40 gallons and get $1,600. And now if Pepsi's best response is 40 gallons, Coke's best response is going to be 40 gallons, so they are both playing a Nash equilibrium, a best response, and thus they are mutual best responses, and this is a Nash equilibrium. So I'll just put a check here and say, great job, Pepsi. All right, now we're told that a new company, RC Cola, enters, and we're given a true-false question. Would producing 80 gallons be a Nash equilibrium? And I want you to think about this for a second. A Nash equilibrium is a set of mutual best responses, so would 80 gallons be a Nash equilibrium? So on reflection, you probably said, no, 80 gallons is not a set of strategies. 80 gallons is like an amount of liquid. A set of strategies would be that Pepsi makes, say, 10 gallons, Coke makes 7 gallons, RC Cola now would need a strategy because it's playing, they make 36 gallons. A Nash equilibrium has to describe what each player will do. So this description of 80 gallons might be a description of like the total amount produced, but it isn't a strategy for any particular firm. To talk about a Nash equilibrium, we'd have to talk about 3 specific amounts that might add up to 80. So probably the best, most generous interpretation of this, which will still make it false, is that the Nash equilibrium would be each firm making 80 over 3 gallons. And you actually analyzed an identical situation to this on the problem set, in problem set 6, and what you did is you calculated what each firm's profit would be. You calculated what it would be if they produced 5 extra gallons or 10 extra gallons, and you saw that it would go up. So these would not be best responses. So B is totally false, 1, because it doesn't make sense, and 2, because as you showed on the problem set, it would not be in their best interest to stick to the agreement. None of the firms is playing a best response. Finally, we're asked, true-false, as the number of firms becomes very large, this market will tend to resemble perfect competition, and the price will fall to marginal cost. That is true. So B is false. C is true. It's not something we can see easily, but I think maybe by calculating the Nash equilibrium strategies, when there's 3 firms, you'll see that Together, they produce more than when there's 2 firms. And then by analogy, if there were 4 firms, they would produce even more. 5 firms, they would produce even more than that, and so on. And the limiting behavior would be, as you add more and more and more firms to this market, together they produce more and more and more, and we get closer and closer to selling for marginal cost. In this case, selling for 0 and producing a quantity of 120. So let's calculate the Nash equilibrium. Well, we can't really calculate, but we can verify the Nash equilibrium when there's 3 firms. And I'm going to say, suppose that each producing 30 is a Nash equilibrium. And then in total, they would produce 90, which is a little bigger than our Nash equilibrium in part A, which was 80. And we're arguing this makes sense because there's more firms, so they produce more in the Nash equilibrium. So to verify that's a Nash equilibrium, we'd have to make a similar table to what we did for part A. Get this shit out of my face. All right, there we go. So we'll make another table of Pepsi's profit, but now taking into account that each of the other firms are producing 30 gallons instead of like earlier where we had Coke making just 40 gallons. And we'll consider Pepsi's profit if it made 20, 30. 30 would be sticking to the agreement, 20 would be making a little less, and 40 would be making a little extra. We'll find what the price would be for each of these quantities, and then we'll calculate the profit. And what we're trying to verify is that Pepsi sticking to 30, sticking to the agreement, is its best response, and thus if it's Pepsi's best response, Coke and RC are identical, so they would also be doing their best response. All right, so if Coke and RC each make 30 gallons and Pepsi made 20 gallons, then there would be 80 total gallons, the price would be 40. If Pepsi made 30 and the other 2 each made 30, there'd be 90 total gallons, and the price would be 30 according to our table. And then finally, if Pepsi made 40 gallons and the other 2 made 30 apiece, there'd be 100 total gallons, and our price would fall all the way to 20 according to our table that you downloaded in the Word document. Now we can calculate the profit. Remember, there's no cost, so profit is just going to be our revenue. 20 times 40 is $800 in profit. 30 times 30 gives us 900, and 40 times 20 gives us 800. So we can see 30 is indeed a best response. So our hypothesized situation where each produces 30, and we said that those are all best responses unless the Nash equilibrium looks like it's true. You could go on to do this for 4 firms. If there's 4 firms, I don't know exactly how much they'd produce in the agreement, but I think they'd produce 25 each, and you could go on to verify that that's a Nash equilibrium. So for homework, verify 25 gallons as a strategy for each of them is an NE for 4 firms. And I'd strongly recommend using these like profit tables, Pepsi's profit table like we've been doing, because you want to, keep all this information organized about if I did 25 like the agreement says, what would my profit be? What if I did a little less, like 20? What if I did a little more, like 30? And so on. I guess that wouldn't actually work. You'd have to do like 10 more or 10 less. So thanks for watching. This is the last of 4 review videos that I will be making. In summary, if you still have confusion, make sure you come to office hours, come to the review session on Sunday, come to office hours next week, use the head TF's office hours. There's a lot of resources available. So when you get stuck on something, don't spend too much time brooding over it, because then you just get really confused and frustrated. Give it at least 10, 20 minutes to figure it out, maybe 10, 15 minutes at most to figure it out, and then just write down a note to yourself to ask a question by email or at office hours. All right, see you guys on Sunday or Monday if you don't come to review.